Today on Tech Uncapped, 15 months from a lab in Poland to a SpaceX launch. Now they are listing on the Warsaw Stock Exchange. How do you move that fast? I'm Peter, joined by co-host Dr. Red Boumghar and our guest Tomasz Palacz, CEO of Liftero. Let's get into it. Welcome back to Tech Uncapped. Today I have the honor of having Tomasz from Liftero on the podcast, and for the first time we have Red on as a co-host.
Hello,
Red
guys.
and I, hello. Red and I, we hit it off in season 3 or episode 3 of Tech Uncapped, and decided that it might be good to have a co-host on for this talk today. So welcome, and Tomasz, let's jump straight into it. Let's start about who you are, and tell us a bit how you got into space and how you started your obsession with rockets.
Yeah, sure. So, well, first of all, hello, and thank you for having me. It's a pleasure to be here. So, I'm currently a founder and a CCO of Liftero. We are a space propulsion company based in Poland. So we build basically rocket engines for satellites that they use once in orbit. And yeah, we've been on the market for a couple of years, having a lot of things going on. We went through a lot of things, and currently we finalized the development of our first product, which we currently offer to customers, and it's going very well. We see very good tailwinds blowing into helping us to push the product on the market, and so far it's been really successful.
That's great, Tomasz. Take us all the way back to the start. Just tell us how you started. You started as pretty much as a two-person garage project. Is that correct?
I started Liftero with my co-founder Przemysław Droszcz, Przemek Droszcz, and he's still with the company, obviously. And we were a two-man team at the beginning, and we actually met at the university in Kraków where we studied. Back then already, for like 4 or 5 years, we worked in this student club, student society, focus on these engineering projects, and we actually kickstart the rocket propulsion section there, right? So these were very student projects, so I would say pretty dangerous, but because we were students, we had, I think, God mode, and we don't have anymore. But thanks to this, we survived a lot of explosions and this kind of stuff with rocket engines, but we built quite a few. We were lucky enough to be able to travel to different events, different competitions, across the world with our basically sounding rockets, like small rockets, demonstrators, and this is how we get hooked in the space industry, and this is how we learned the technology basically by ourselves. And at the same time, this was the years when SpaceX were doing first landings, and this was all very inspiring to us. And 19, when we graduated, we decided, okay, let's set up the company. Actually, that was it. And at first, we knew that we wanted to do something about, well, our knowledge, our expertise, which is propulsion. But and our first thought was to do basically build a launcher, because which rocket scientists don't dream about the launcher. But I think we're pretty smart enough to know that it's maybe too late. Maybe we won't be able, starting in Poland, where space back at the time was really not popular at all. So we would have a very hard time finding a funding, and we made a decision to go into the other direction. Okay, so not build rocket engines for launchers, but build them for satellites, because it was a boom for small satellites. So there was a gap on the market that we saw. Let's build a small rocket engines that can be put into satellites and work into that direction. And for first few years, we were actually working mostly for within ESA projects, ESA contracts, EU projects, learning the market, talking to customers, and of course doing our R&D in different technologies. But it took us a while to understand it well, because you must remember that we were basically graduates from the university that at the time had no proper space faculty, right? So we were basically self-taught, both about technology, about rocket propulsion, and also about the market, the business. So let's say around 2023, we knew what we want to do and how we want to do it. We had the idea of orbital transfer vehicle, like a taxi for satellites, which of course was based on our core technology, which is green chemical propulsion. But we, let's say, after doing a very thorough analysis of the market, talking to customers, they told us, don't sell me the taxi. I don't want to be on your spacecraft. I just want to buy your propulsion. And so here we are, basically offering this propulsion as a subsystem for satellites, like a piece of hardware that we deliver.
And why was it that they didn't want the full package? What made you realize that this is what we need to dive into?
Yeah, I mean, this is pretty complex, and I would talk about this hours. But in short, let's say this is solving, in theory, let's say this is solving the same problem, right? It's how about move satellites in space or change the trajectory, how to deploy satellites in the orbit that you need. And of course, we wanted to build a spacecraft because it's more ambitious. We can operate the spacecraft. We can have like a fleet of them. And so we are, let's say, higher in terms of value chain. And also we thought about this idea because we thought that it will be easier to sell it to VCs as well, because they are always looking for some big ideas and big projects and something that can have a lot of potential. So this was quite a novel thing, and I think still is. But the problem is that it's not solving the entire, let's say, transportation issue, because at some point you need to drop the satellite, deploy the satellite, so it's no longer on your taxi. So the satellite still needs the propulsion. So the customer still needs to buy the propulsion system, and also it's related to how much capital you need to deploy to build the service and how much it costs you versus the potential revenue that you can get. And also orbital mechanics is not favorable for this application. And I can give you an example of Starlink, right? If the LTVs would be a good way to deploy massive amounts of satellites, then probably SpaceX would be using them. And that's not the case. Starlink satellites each of them use their own propulsion to get where they need to get to sustain them in orbit and avoid collisions. All that propulsion is needed. So the customers basically told us, let's sell me the engine, don't sell me the entire service.
No, fantastic. Tomasz, if I may, for people listening, so I guess when you launch something in space, you use a rocket. So you put your satellite on a rocket, and the rocket would put you close to an orbit. And that's actually what you call about getting to the final orbit slowly, which is not too far from where you've been put. And that's the quality of the rocket that does that. And I guess that's why you need the propulsion on a satellite. So I guess you were thinking of a taxi that gets you from the rocket to the orbit. That's what you were talking about.
Yeah, exactly. So this is kind of a last mile delivery in space, right?
I see, last mile delivery.
Yeah, you travel like a 90% of a distance using the rocket, right? It drops you at this hub orbit, and then from this hub orbit you get to your destination using this taxi. And the idea was that this taxi can move to different orbits, but it's basically much more efficient for each satellite to have their own propulsion and just go different directions.
So from that you pivoted from taking your taxi propulsion system and selling just that for others, right? All right.
Exactly. Fantastic. So on the business side, you are solving the complete problem for the customer, like end to end. So it's not only about getting to the final orbit, but it's also about keeping this orbit, right? So there are forces that constantly try to take your spacecraft down to Earth and so on. So you need to kind of have a propulsion to sustain your orbit and increase your lifetime in orbit to generate more revenue. And also you need to avoid space debris, other satellites. You need to deorbit end of life, and so there are many let's say that the customers want to make. Also, the propulsion solves all that, right? So why invest into other stuff? And also, it's much less capital intensive to develop the propulsion subsystem. And manufacture that in like, even hundreds than to build entire spacecraft. You need to operate them, you need to manage the missions. It's very, very complex, right?
Yeah. So I suppose your propulsors have a certain size, and so and in space, if you have a big satellite, you need bigger forces to move it. So who are your ideal users
Yeah,
for your
okay.
system?
So we have currently one product on the market. Of course, it's based on this chemical propulsion technology, and we like to think that we are pretty smart about how you can configure our system, and we have this scaling idea in our DNA. So from the scratch, we wanted to develop a product that can be manufactured in series. So we made for constellations. So we made a lot of product engineering decisions early on to allow it. And so we have standardized our components, like for example, thruster, the fuel tank, like a Lego blocks basically. And from these Lego blocks, when the customer comes to us, he says, okay, I have this and this room, right? Exactly, I have this volume that you can use to put the propulsion in, and we can easily configure these Lego blocks into this volume to make this. I don't like the word custom because customers don't like custom systems because they expect it will be super expensive. So it's more like a mission configured, mission specific system, right? So to answer your questions, we can serve satellites between like 30 kilograms to 500, but we have some discussions about larger systems as well, right?
Okay,
and, yeah, it's more related to what the customer wants to do, how much mobility it needs than the spacecraft size itself.
And Peter, I know you visited them, no? Their lab.
Yeah. So I think we met about a year and a half ago. I was introduced through a friend of a friend who was invested in Liftero, and so I went to see your lab in Kraków, which was quite amazing. You were just about the time to plan to your first mission, I believe, with hitching a ride with SpaceX.
Yeah, correct. So yeah, I think it was late 24, right?
Yeah, it was like in between Christmas and New Year's, where I went to see my in-law family in Kraków as well.
Yeah, it was pretty hectic time. Yeah, that's true. So and this is the thing that we are really proud of. So let me go back in timeline. So let's say around half, like mid 23, we secured funding. We started to work on this OTV, mainly propulsion. In early 24, we decided to do, okay, we need to switch to propulsion hardware, to propulsion subsystems, and immediately early 24, we decided, okay, let's do a demonstration mission of our first product. Not even a prototype, like a first product that we could offer to the market, right? So we bought the satellite platform from this company in the UK, and within 1 year from the first prototype of a booster, our product, we managed to develop a flight model that we delivered integrated in the satellite. And by the end of 24, it was already done and waiting for the launch, which eventually happened in March 25 on board SpaceX Falcon 9 launcher. This was like a rideshare mission where many other satellites were launched. Throughout last year, basically, we've been testing this product and this propulsion, and we have a very good data. We actually confirmed all functionalities, and we have a very good data set proving that it works without any anomalies, and we are very proud of that.
Wow, fantastic.
That's amazing. That's awesome. And so you have good 12 months of testing data where it's been in space and working now?
Yeah, correct. So first of all, it does job as we expect it to do. So it changes the orbit. So this is the most important thing for the customer, to change the orbit with given performance and so on. So this is what we already proven, and actually everybody can go online, and because all the satellites are tracked publicly and this data is visible, you can see what is current orbit, how it changed over time. So we can always look up our satellite and see the results of our testing. And of course, We have a lot of telemetry of internal data. We compare it to how it looks during ground testing and compare are there any differences, because you can expect always that in space there may be something different. It survived pretty dangerous environment in the launch, and also radiation. All that can impact your system. But after 1 year, we are happy to say that we notice no degradation, no anomalies. So this data proves that we have actual flight heritage. This builds confidence.
That's very nice. Yeah.
The product, from our customers, and this was like a major milestone that we achieved recently. And now we are, let's say, turning this and all that work into commercial product. We started signing first contracts. Actually, one was already delivered early 25 for a first customer. Now we announced another contracts, and I hope to have more in the near future, as we see huge demand, and we are in a lot of discussions for the deliveries.
Well done, well done. Yeah, there's a big thing in the space industry which saying that says anything that has never flown would never fly, and this is kind of a paradox. But you broke that, so you have something in space. So congratulations.
Yeah. Thank you very much.
I guess that must also like that's the traditional like proof of concept you put through now, yeah. And I can imagine that in this industry people are probably fairly skeptical of newcomers and want to see some very solid data before they will even want to talk to you.
Yeah, definitely. I mean, as I said, this is like a trust thing, right? How can I trust whatever you do on the ground? Because eventually, space verifies if it works or not. So this is, perfectly understandable from a customer perspective, because once, they commit, they buy, they pay a lot of money for something to integrate in the satellite, it launches into space, goes through all this process, 1 year or 2 years of satellite preparation, and then it fails, all mission can be a failure. So there is a high stake in selecting these subsystems. Propulsion is especially difficult and controversial because it likes to fail. I think in terms of like statistics, it may be one of the most failing subsystems in space.
Is it? Okay.
Look, even if you look at the top companies, like a very huge prime companies, take famous Starliner docked into ISS, not of able course, to bring humans back to Earth, and this is like a multi-billion-dollar program, right? And
exactly.
And the thrusters are failing, so this is not easy to build reliable propulsion.
Incredible.
Your type of propulsion that's chemical, right? Could you briefly explain the differences between the two types and why you prefer the chemical one?
Yeah.
Maybe the third type as well, which is gravity-based. Which is
gravity-based. Yeah.
Yeah. I mean, well, I'm a fan of Newton's law, so.
That's very good.
So you need to expel some kind of mass. I mean, yeah. So basically, to move around in space in any meaningful way, you need to have a kind of a rocket engine, right? So each space propulsion is basically a rocket engine, but it can generate thrust, the force, in a slightly different way. And there are two main categories. One is chemical, and the other one is electric. Electric still use some kind of fuel. A common misconception that electric is like with electric car, they have battery and somehow they produce thrust. No, they still use fuel, but with chemical, it's like, you have this fuel oxidizer, you mix two of them, combust, and expel the mass at the hot gases through the nozzle, and so you can push a lot of mass through this rocket engine, and this produces pretty high thrust but consumes a lot of fuel, right? So that's the characteristic of a chemical, which, let's say, translates to very fast maneuvers, but you need a very large fuel tank. And the electric is the opposite of the spectrum, because it basically works on the individual particles, let's say, of some gas, and it ionizes the gas, so splits into like positive and negative ions, negative particles. And you can influence these particles with different kind of like electromagnetic forces. There are many technologies how to do that, but eventually these individual particles are accelerated to enormous speeds through the nozzle. So this is other side of the spectrum, because the mass that you are accelerating is very low, so you cannot push much fuel through that engine. But on the other hand, the velocity, the speed at which particle leaves the engine is very high, and so this translates to very low force, very low thrust, but extremely good fuel efficiency. If you want to sustain the engine operating for a very, very long time, then you can do that, but you will generate this force at much lower amplitude, which will lead to very long maneuver, right? So
Nice.
we decided to go with chemical mainly because of this advantage of high thrust and very fast maneuvers, because our hypothesis is that more and more customers will turn to chemical because time is of essence, and now time is money, time is safety, all that. I need to be at a given point at very fast, not very slow, right?
I have a question about that, actually. I want to hear about what you think about what the orbit is going to be. So, and I explain, we've seen beginning of year 2000s satellites that are getting more agile on their axes. So, meaning they can turn left, right, look up, look down, or turn around completely. But now what you're offering, and it seems like you're offering more fast agility in moving orbits. So what is it going to be if every satellite pretty much has the same capability in orbit? Like, are we going to have like regular orbits or a big mess of things moving quick?
Yeah, I think already it becomes like that, but I don't really like this. I don't appreciate this catastrophic visualization of how cluttered the Earth orbit is. For sure, you must have seen that, right? Because it's very not to scale, so it's pretty empty
Of
out
course,
there,
yeah.
right? And the collision.
Yeah, each dot would be big like Paris, pretty much like.
Yeah. Yeah, and so the collision probability, although it's growing exponentially, it's still not that high, right? Of course, we need to do something about it, but well, I think the orbits that the satellites are moving around, they are not determined, I think, explicitly by what kind of propulsion they have, but what kind of application they are used for, right? So if they are air observation, they want it on this very particular orbit. They have a communication, they want something different.
Yeah.
GPS is on like a medium Earth orbit, so they need to be pretty high. Then you have geo orbit, and I don't think that will fundamentally change. What I think will happen is that every satellite will have more and more mobility. And for example, let's say the collision avoidance, right? So as I said, the number of satellites deployed into orbit will exponentially grow the number of possible collisions that may happen. Every satellite need to do kind of a collision avoidance maneuver. I think in 2025, SpaceX Starlink was around 10,000 roughly satellites in orbit, and they did, I think, over 300,000 collision avoidance maneuvers, right? So imagine if we have like 5 times that number in orbit, it will grow significantly. And so you can spend doing 2 days on doing this maneuver, your satellite, or you can do it in like a few seconds with chemical propulsion, and then continue whatever your mission is, right?
Fantastic.
Tomasz, with this data, you mentioned you're starting to get clients now. And so tell us a bit about the clients that you have and how it's now turning into a commercial operation from after proving your concept and now having a real product in the market.
Yeah, so we see several segments based on the application that we currently target, and we target the obvious missions where the chemical propulsion have advantages over electric, and one of them, for example, is in-orbit servicing, which is kind of a service or do something about other satellites in space. So you can already see how the space industry is actually grown, because there are space companies who are serving other space companies in space, right? So this is like a in-space
chain.
Economy. Yeah, I mean it's a lot of that is driven by geopolitics and to have these capabilities just in case, right? And this is driving the market. So in this segment, for example, the chemical propulsion is required because you need to do a lot of impulses, a lot of maneuvers in different directions. You need to react fast. You don't have time to two-day firing of electric propulsion, so that's where it's no-brainer to use chemical propulsion, right? So this is where we start. We also see this very interesting trend with so-called re-entry capsules, re-entry spacecrafts. So this is also a very interesting segment where there are these companies often related to industries here on the ground, like semiconductors or some biotechnology, and they want to launch this capsule into orbit, do some kind of research or production that only can be done in like microgravity in space, and bring this back. And this manufactures, usually very expensive materials, very expensive, specimens and all that. And this already becomes a very good business. And for that, for precise deorbiting, precisely bringing those capsules down, they also need chemical propulsion. So these are the let's say the obvious segments that we currently target. But our end goal and the best customers that we target are basically constellations. So we have this scale in our DNA, and we designed our product from scratch to be able to manufacture that in high volume. And we see that now there are not very many companies, or basically close to none companies in propulsion overall in globally that can deliver hundreds of propulsion systems in a short time scale. And often this is what the constellation require. Like in a few years, we need to deploy, let's say, 500 propulsion systems. So this is like a industrial production already, compared to like one shot production that was done traditionally in space. And also we are actually preparing our production capabilities to be able to meet this demand.
So by what time horizon will you have? Did you say like 500 was the manufacturing capability or demand that there is?
Yeah, I doubt anybody has this capability. Right?
Yeah.
So like, as I said, traditionally these satellites, these subsystems were made in like few pieces tops, right? So this is what the industry is used to. And now, a lot of industry needs to switch to more industrial approach and serious production and so on. So I think in many subsystems, not only in propulsion, but in many subsystems, this is a bottleneck. And so customers, the satellite manufacturers, integrators come to us and ask from the constellation side, not about one piece or two pieces, but okay, can you manufacture 50 or 100 by end of next year, right? And I think honestly, for most space propulsion companies, the answer is no. At least they cannot do that reliably. Every piece is the same. Every piece works in the same way. And this is not only related to like infrastructure, the facility that you have, but also the product, like how easy it is to manufacture, what kind of exotic materials and processes do you use. And we basically, our operating principles are that to eliminate as much as we can and just use as much as we can from the industrial base from, let's say, automotive, right? So it is much cheaper, much more available, and we don't rely on any exotic space supplier that could be a single point of failure in our supply chain. So and now I think we estimate that our production capability is up to 40 thrusters per year, and this will translate probably to, let's say, 10, 15 propulsion systems as a whole. So basically products, but we need to increase that significantly, like 3, 4, 5 times that to meet the incoming demand.
Yes.
Speaking of manufacturing, how much do you plan to base in Poland, and how does the supply chain look like? Do you get a lot of things done in China?
Well, of course, we try to avoid it as much as possible. Some prototyping level, it can be sometimes handy to use China manufacturers, but overall, when it comes to our product, we don't do that at all, right? We of course want to be Europe first and be kind of independent in that. And as I said, we are pretty happy in eliminating complex stuff from our supply chain. And of course, electric components, microcontrollers, all that. Europe cannot produce all of them, right? So we are reliant still on non-European sources, but I think most industries are. But when it comes to the potential point of failures, I think we don't have much. So we can manufacture 95% of our propulsion system here in Poland, even if with our own facilities, but also using the external supply chains. And probably by the end of this year, we'll eliminate this remaining 5%, which is non-European.
Very nice. So heavy percentage in Europe, I see. Congrats.
And so you did say in Europe, but it's not all Poland. There will be other places that you source from.
Of course, we want to leverage the advantage where we are, and actually Poland has pretty good industrial capabilities. And since we don't have much competition here, and we can leverage the supply chain. I would say that definitely the majority of our suppliers are from Poland, because as I said, from we don't use off-the-shelf components that are specifically made for space. Because usually they are produced in low volumes, they can be a bottleneck, they can be very expensive. So if we have such component in our system, we usually take it in-house and design it our own, so we have full control of the manufacturing process, right? So when I'm saying about manufacturing, excluding the electronic part, it's basically that metal came in to our facility or to our partner facilities in the supply chain, and then our product will come out.
Okay.
When I visited you a year and a half ago in your lab, you had this really cool machine, which I think it was like a 3D printer, but the 3D printer was printing in metal. Do you mind just explaining briefly what you make with it and how that works?
Yeah. So definitely. So this is like additive manufacturing. So it's kind of the opposite of what is typically done, and I think it's very popular right now. And so you can achieve like very close to final shape already from the printer, and you can achieve very complex geometries that are not feasible with other methods. So that's why it's very popular.
Very fine. Okay. Oh, good. You must be inspiring everybody around you, I guess. When you do propulsion, that means going to space. So what is the activities around you? So are you involved in meetups, in groups, in communities for space?
I mean, yeah, definitely the ecosystem in Poland overall is growing, and we kind of follow the same trends as everybody, moving towards more like deep tech hardware, and also space tech is growing in popularity, and especially here in Kraków, the startup stage is pretty advanced, and it's a very good place to be here and build here. But I think in space industry we are the first hardware company in Kraków. So on the one hand, of course, we cannot easily, let's say, recruit people from the other companies or whatever. We don't have access to the well-trained, experienced engineers. But on the other hand, we offer kind of a unique thing here when it comes to the jobs. Right?
Nice. So it's hard to select candidates.
Would you say that the Polish space industry is in a very interesting, growing place right now?
Yeah, I mean, definitely. Like over last, let's say, 10 years, it was tremendous growth. So I think Poland joined European Space Agency in I think 2012 or 13. So not that long time ago, right? And there was like a transition period for the companies to be able to start doing business within ESA and build relationship with the ecosystem. And now finally. Polish government is actually buying satellites from the Polish manufacturer, like end-to-end system. So this is something that was not done previously. We were always buying some capabilities from abroad, and now we have this capabilities within our industry. So and it's growing very fast. More and more companies are being founded here. And so we can also see in the public spending, of course, from the defense side as well, but also the kind of a subscription or the contribution from Poland to the European Space Agency, which I think grew a few times in the last 3 years. We sent our second astronaut from Poland.
Yes.
recently, and this also was a huge boost and a huge milestone for the industry as well. So definitely we are on a wave.
Very good.
Great. And you mentioned, I think you said that when you are inside of Krakow, you are the only company there, or did I get that wrong? But is there like a cluster elsewhere in Poland? But also the university where you come from Krakow, is also has a specialization within space as well, right?
Yeah. I think definitely when we started, a few years back in Krakow, we were one of the few space industry companies. There are other who mostly deal with like a downstream, so they are more on the side of using the space data and this kind of stuff. But Poland is a big country, so there are other places where the startups and actually mature companies are based. A lot of them are based in Warsaw, the capital, obviously. Other cities as well. It's just characteristics of Krakow that it was often it's more dominant when it comes to like digital startups, services, this kind of stuff, right? But we see this changing, and we also see from local government and the city mayor pushing towards more like deep tech innovation. And one of the things that you mentioned is that finally on this AGH University in Krakow, which is like, let's say, top 3 technical universities in Poland, they finally managed to open a proper space technology faculty, right? So now the experts are coming, and we are getting graduates from this faculty. So everything is moving in the right direction. And I may also point to one more thing which could tremendously impact the Polish space ecosystem and also defense ecosystem, is that now Polish government is in kind of advanced discussions with European Space Agency to set up European Space Agency ESA office here in Poland, right? So that would bring a lot of know-how, a lot of experts, a lot of funding, and I think around that ESA office, ESA center could be a new cluster or ecosystem of companies built. And Krakow is actually one of the cities that are trying very hard to convince the government.
Very nice.
It should be done in Krakow, right?
Yeah.
Very nice.
Well, fingers crossed that it's going to be there then.
Yeah,
Indeed.
yeah. We are looking forward to be neighbors with ESA.
Yeah,
Exactly.
yeah, that would be cool. Yeah. Speaking of neighbors, I think it's no secret that Ukraine is a neighbor to Poland, and Krakow to Lviv is only 300 kilometers. Lviv is the westernmost city in Ukraine. How is the war in Ukraine affecting how you think about tech and defense in Poland particularly?
Yeah, well, I mean, obviously it impacts the defense industry very much, and Poland is spending a lot of money on defense recently, increasing its budget. So part of it also relates to space as well. So for example, these mentions of the Polish government buying the complete satellite systems are part of this. This trend. But when it comes to our operations, of course, it have its consequences, but we are more thinking globally, right? So we have customers from India, from Europe, from the US, and so of course the local mobilizations initiatives are important, local factors are important, but space is kind of a global business, or at least regional, right? But when it comes to how the life looks here and so on, it's basically, let's say, the same, right? We have had an influx of Ukrainians here, which also helped a lot, and it's still pretty safe. So we are I think in a good place here.
Yes, I guess, like as you said yourself a bit, space overlaps quite a lot with defense these days for various reasons. There's of course satellites, and Starlink has played a huge role in the war in Ukraine, and then we're moving towards wars that are like purely dominated by drones and robotics, which then also needs connectivity, either through a fiber optic cable or through an internet connection.
Yeah. I mean that's one of the examples of how the space industry impacts the, whatever happens on the ground. And this is always the message that every, I think, space industry company want to give to the world, that it's not something that we are doing out there, it's our hobby or whatever. No, it's something that have meaningful and more important impact in the other industries as well. Safety, security is of course the big one, and now it's even more pronounced, but there are many examples that one could give how the space industry is contributing to the economy and actually everyday life, right? So we are in a very far away when it comes to from like everyday Joe, and we are providing rocket engines to satellites, which means basically nothing to everyday Joe, but we are contributing to building this satellite infrastructure, improving it, making it work better and more efficient, more economical, and it directly impacts the life here on the ground.
Yeah,
fantastic.
So one topic I like to always bring up, and which because it's always relevant, whichever type of startup you are, is in regards to funding. And can you tell us a bit about your journey and experience on getting VC funding and struggles and opportunities you're seeing now in terms of getting further funding?
Yeah. When we started like 2019, 2020, we started to look at the funding. Of course, pandemic and so on. But back in the day, and I think it still is, very hard to fundraise for a deep tech company early stage, and definitely back in the day, the Poland was not a good place to fundraise for space tech. I think it's changed tremendously over the years, but we managed to have our funding round with VCs in 2023. With VCs, and they believed in us early on, and they are still with us. And and then we follow up with more investments from private investors. Eventually, we are now looking into doing an IPO on the small stock exchange in Warsaw, which is called New Connect. So this is like a stock exchange for early stage companies, and I think it's unique. There are some, let's say, similar stock exchanges across Europe and other places, but when I was comparing what kind of companies and what kind of path you need to take to go there, I think it's kind of different, and we see this possibly as our funding unfair advantage over the competition, right? Because it's much less overhead than fundraising with VCs, and at the same time, now the situation in Poland is that there is huge interest in space industry, especially from the capital market, and there are only 2 space industry companies on the Polish stock exchange, and both of these companies actually already walked this path, and so we are following their footsteps, and investors see that they are success stories because they are, and so nice. We see this as a very good move. But once there, if, for example, I don't know, you need capital because you want to build up your production capability because you've secured huge constellation deal, right? Then it is possible to raise the amount that you need within a few days, right? So you're already a public company, so you can issue the shares, and this is much easier to do. Of course, this have its own peculiarities. It's not only but this is definitely some kind of alternative that we have here in Poland, and the space companies are actually following down this path because it's a very good sentiment on the market right now.
It feels pretty unique to Poland actually to have a national IPO and being able to leverage this. It's very nice that you're trying to go there. I feel like you're very capex intensive. So as soon as you get a big contract, you need to produce. So you need to buy eventually new machines and things like that. So you really need that. Sorry, there's a party next to me, so I hope you can't hear them.
I got excited.
Yeah, they got excited just for that. But I guess the excitement is on the world space industry because there are like different launches. We've seen ISAR being scrubbed yesterday. I guess, Peter, you wanted to cover that. Does it have an impact on you guys at Liftero?
I mean, not directly, right? I mean, we always have our fingers crossed for fellow space companies and especially launcher companies here in Europe, because as good as SpaceX is, right, it's basically a monopoly right now. Of course, you have players like Rocket Lab and few others which can give you a lift using their small launcher, but it's nothing comparable, price wise at least to SpaceX, right? So SpaceX is, I don't know, probably moving like 90% or launching 90% of all satellites of Western satellites, let's say, into space now, and we need more. We need diversified options, and of course Europe is struggling to build their own capabilities. Now finally we have operational launchers like Ariane 6 and Vega, but these are, let's say, I think they are built like an older generation, right? And everybody is racing, like everybody, there's many companies in Europe racing to build these new generation launchers and eventually make them reusable like SpaceX, so we can finally catch up, right? So it impacts Liftero and similar companies in the way that if there are more launch opportunities, the market can move fast and everybody can benefit from that. The market can grow much faster because launch is one of the major bottlenecks that it is still there.
Yeah, 100%.
One of the big topics of this podcast is basically about European sovereignty as well. And of course, we talk about what works and what's great in Europe and how we catch up to the Americans or the Chinese. And so having that launch capability in Europe, I guess, would be going from 0 to 1 in a way, right? It is something that would be great to have in Europe.
Yeah, I mean, exactly. This is right. Of course, Europe is a puzzle of different countries, right? So now
Yes.
there is the situation that each significant country that have significant space budget is trying to build their own launcher. So either is like German, of course, and you have a launcher company in Spain, in France. There are several of them, right? Key question would be: is the kind of a market can sustain them all, or how many can be sustained using only like European payloads, right? So on the one hand, of course, we need these capabilities, the sovereign capabilities. On the other hand, it's more, I think, on the nation level than the Europe level by itself, right? So you may say that, because of this race, there is a lot of funding that will go to waste because eventually something needs to happen about these companies. There is not enough market, at least yet, definitely not a local market, but I think this is the path that we need to go and see who will come on top. And I think we shouldn't be only closing our mindset within the European box. We should definitely try to bring as many to Europe as we can.
Sure. Yeah, I mean, space has also been interested in the sense that even though you had the Cold War between Russia and the West, you still had collaboration with the International Space Station, and for a while we sent our astronauts into space to the Russian launch station as well, right? So there is much more collaboration than there is actually on Earth in a way.
Yeah, I think that's a positive way, and then it gives a good message that if needed, we can collaborate, and this is a final frontier, right? So this is completely different than to look at the space industry as a commercial market or space industry as a national interest market, right? This is like a humanity or mankind basically exploring the outer space and using it to our benefit, right? So these things definitely happen, and I hope that we can in the future collaborate on much more levels.
Yeah. Before we wrap up, because we are kind of running a bit over time now, but I just want to go back to your IPO. Do you have a set date for it yet?
Yeah, so it's in progress. So we will be doing a fundraise within, I think, 2 months. So we will be rather quick with what we have lined up, and then of course we'll be filing documentation papers, and we'll be waiting for the decision from the stock exchange. But I think between second quarter and third quarter, around June, July, we could expect to be a public company.
That's very exciting. Wow. And is the whole process working like a typical IPO? So you have somebody to underwrite it first that says we're going to take this much shares, and then we go public. So you kind of know how much you've raised before you actually go public.
Yeah, exactly. This is the way.
Fantastic.
Okay. That's super exciting. Yeah, I mean, you don't see too often that early stage companies do these type of IPOs. So, but you have some track record with the other space companies doing it in Poland, so that's really great. And definitely, when you know the date, send it so we can follow, and just like you would follow a space launch, in the same way. Hopefully, celebrate a good opening.
Yeah, right. Definitely will do that. I hope that it will go upwards to the
Yeah.
moon.
Yeah,
Fantastic.
yeah, to the moon. Yes.
Exactly.
All right. I think on that note, let's wrap up the podcast.
Yeah.
It was great to have you on, Tomasz, and thank you so much for joining in as the co-host, Red. I think it was
You're welcome.
some very good talks we had here and some good
Exactly.
insights. Thank you so
Liftero is
much.
exciting, so fingers crossed for all the success.
Thank you, guys. Thank you for having me.
We had the rapid fire questions, Peter.
Yeah, I think we can do it if you want to, Tomasz, but it was just like, okay, we're already running a bit over time, and should we do it?
It's 2 minutes, Thomas. You answer quick. So
Okay.
yeah, go for it, Peter.
I'm not
Fast
really
ones.
good at it.
Okay, we can always edit it out if it's not good. Don't worry.
Don't worry.
What's a technology that exists today that would have sounded like science fiction 10 years ago?
I think that's the only question that I have an answer when I look at the questions. So yeah, to answer this question, I think unfortunately I need to say AI, like
AI.
LLMs, I'm not a super AI optimist. I think we are not quite there yet, but it really impacted basically my daily life, and I think it have a huge potential. And if you would say to me 10 years ago that we can do what we can do right now with it, with all consequences of all that, I wouldn't believe you. So
All right, that's fair. All right. I think on that note, thank you so much for joining. It was a pleasure having you on, and thanks, Red, for co-hosting.
Yeah. Thanks, Peter, and thanks, Thomas. All the best, and fingers crossed for all successes.